Hello, a great welcome to this series on Abaqus. Myself Jarajan B. This is tutorial number 12 and demonstrates the application of Abaqus in the analysis of a structural bracket. So let us first go through the problem statement. So the bracket that will be analyzed is shown here. As shown, the bracket is connected to a column of size HE 260. Both ends of the column will be considered as pinned. The bracket has two parts. One is the flange and the other one is the web. It is essentially a T section, and the geometry of the bracket is shown here. It is connected to the column using 6 numbers of M24 bolts. The configuration of the bolts is shown here, and the bolts are essentially M24 bolts, and the geometry of the bolt is shown here, which indicates the head dimensions and shank dimensions. Okay, and regarding the steel structural material, both the bolts and the bracket will be of steel with E equal to 2.1 into 10 raised to 5 MPa and a Poisson ratio of 0.3. And regarding the steel structure material, the yield stress will be considered as 355, that is as 355 grade, with an ultimate tensile stress of 470 MPa with a plastic strain of 0.178. And regarding the bolt material, it is class 8.8 bolt with Fy of 640 MPa and Fu ultimate tensile strength of 800 MPa. Plastic strain will be considered as 0.08. So to improve the visibility of this tutorial, it is conveniently divided into three parts. Part A will cover the module's parts and property. Part B will discuss assembly, step and interaction modules. Part C will give a detailed look into the loads, mesh, job and visualization module. So let us visit the Abaqus. So let us start with the module part. We shall first proceed for creating the part for column. So name it as a column. We shall keep all these parameters default acceptable to us. Continue. So let us first draw a rectangle that represents the column flange, and now let us also draw a rectangle that represents the column web. Let us proceed for dimensioning. So we know that the column flange will have a width of 260 and it will have a thickness of 12.5 mm, that is acceptable to us. And now let us proceed for dimensioning the column web. It has a depth of 225 and the thickness shall be kept as 7.5 mm. Okay, so now let us move the web portion so that is CG matches with the origin of the sketcher. So we shall proceed for translating. So we just want to move it. So select the first point, and the second point we shall move to 3.750. Okay, now let us move the flange portion to the respective locations. We shall copy this portion. Okay, now let us also trim this portion. So similarly, let us move this portion to the bottom end as well. Done. Okay, so let us in a similar way trim this end as well. Okay, so we have created the section for the column. Now let us proceed for extrusion. So the length will be 1500 mm. Okay, so as you can see that yes, the part for the column is generated. Now let us first proceed for partitioning the column cross section. So as you can see that this is a one single entity, we shall conveniently partition it into segments as described here. So we shall proceed for partitioning. So go for the cutting plane method, specify the point and the normal. So let us select one point, this one, and normal to this line. Okay, so now let us create this other second partition. Let us select the cells. Done. So let us also create a horizontal partition as well. So as you can see, now the section is divided into 7 portions. Look here. So this is a cross section. So you can say that it is divided into 7 segments. 1 here, 2, 3, 4, 5, 6, 7. So having done the partition and now the cross section, let us proceed for the generation of the bolt holes in the column. So we shall go for create cut through the extrude method. So let us select a plane. So select an edge as well. Fine. So now as you can see that in order to create the bolt hole locations, okay, so it is important that we assign 0, 0 location to this sketcher origin. So now let us see presently where the sketcher origin is. So you can go over here, sketcher options, and in the origin. Okay, so here you will find that yes, one is 63.13, 63.13 one location, and the other location is 70.63. This means that or the origin, this must be at the mid depth. So let us pick the location for the grid origin as 66.88, 0. Okay, so as you can see that yes, now our the sketcher origin is at 0. So for example, if you go back, go to the origin and say that this point is now at minus 3.75 and this location is at 3.75, is indicating that we are at the right origin location. So now let us start drawing the holes. So the location for the hole will be one hole will be at minus 65, to the other, the y coordinate will be 150. Okay, so let us start dimensioning the radius of the circle. Radius of the circle will keep it as 12 mm. So now let us start populating the 6 holes. So select the one circle. Done. So in one direction we have got 2 sets. That is, this dimension will be 130, and in the other direction we have 3 numbers, and the respective locations spacing will be at 150. So we have to do the flip. Okay, So this means that all the 6 holes are being properly sketched. Now we can proceed for the extrusion. So this means that okay, here we require the flange, the holes only in one flange. So this depth will be the thickness of the flange, which is 12.5 mm, 12.5 mm. So this is okay. Yes, you can say that yes, all the 6 bolt holes are now populated in the column flange. Now let us proceed for partitioning the column along the center lines of these holes, because this will surely help us in doing a proper meshing. So we shall proceed in the same way. So we shall go for a different cutting plane and select the cells. Done. So point to the normal. Create okay. So let us again create the cells. Done. So this means we have partitioned along one diametrical axis. Let us also do the partitioning of the z axis as well. So yes, as you can see that yes, now the column is properly partitioned along the bolt center lines. This means that the creation of the part column along with the complete partitioning is over. Now we can proceed for the other part, that is let us proceed for creating the flange portion of the bracket. So we shall create a second part. Let us call it as a BKT flange. BKT flange. And all these parameters are acceptable to us. So continue. And we know that basically it is a rectangle of dimensions 260 by 450. So let us do the sketching first. So draw a rectangle. And dimensioning it. And we know that the width of this flange plate, it is a 260 mm. 260 mm. And the depth is 450 mm. 450 mm. Okay. Now let us move this to the origin of the sketcher. Shall move to a point of 130, 0. Okay, fine. Now we are ready for extrusion. And the thickness of the flange plate for the bracket, it is 16 mm. Okay, yes. Now let us start populating all the 6 holes on this flange plate as well. So we shall proceed in the same way. So go for extrude cut option. So select the plane. Okay, fine. Now let us start drawing all the 6 holes. Now here you can see that the the origin, proceed for the setup, and going to the origin, you find that yes, the origin is at 0 only, so it do not require any kind of a modification. So let us just start drawing the one hole first, and that will be obviously at a location of minus 65, comma, and that will be at 150. Okay, so let us dimension it, and this will be of radius 12 mm. And now let us start populating the other holes through the array copying option. Select the 90 and done. And in one direction we have got 2, and this dimension will be 130 mm. 130 mm. And in the other direction we have 3 numbers, and this dimension will be 150. So this means that we have to do the flipping. Okay, so all the 6 holes are correctly populated. We can proceed for the extrusion. Done. So okay, this is okay for us. Okay, so this means that all the 6 holes are properly created in the part for the flange plate. Now let us also proceed for partitioning this along the bolt center lines or the hole center lines. So we shall proceed in the same way. Face, define the cutting plane, point the normal. So yes, we may have to do now 2 more partitions in the vertical direction. Okay, so this means the partitioning of uh, the flange plate for the bracket along the hole center lines is complete. Now let us proceed for creating the web portion of the column bracket. So this is okay for us. So let us create another part. So let us call it as web bracket. Okay, so all these dimensions are accessible to us. So the dimension for this will be 284 by 450. So draw a rectangle, and this dimension is 284, be 284. Okay, and this dimension will be kept as 450 mm. 450 mm. Okay, now we need to create a small splay portion. That means we need to cut along this side, along this portion, and let us draw first of all a line, and then we will use our dimension feature. Okay, now let us see what is this dimension. And this should be our 300 mm. And now let's see the other dimension as well. Yes, this dimension should be 200 mm. Okay, so now what we can do is we can delete these portions, the balance portions, using the trim option. So delete this portion. Also, we can delete this portion, yes. So as you can see that the sketching is over. Now let us proceed for the extrusion. And the thickness of the web portion will be 20 mm. Okay, so you can see that, yes. Our portion for the plate is also, that is a web plate for the bracket, is also complete. So this may not require any partition. If at all some partitions are required, we'll see during the meshing operation. Now let's just straight away proceed for defining the next part, that is our bolt. So let us create the part called the bolt. So this is my bolt. Okay, and all these parameters. Okay, this dimension we can reduce a little bit, 200. Continue. So regarding the head dimension, I think it is 40 mm by 15 mm. So let us start drawing a rectangle, a circle first, and the circle, the head dimension. Okay, and let us quickly see what was our dimension for the head. So it is head diameter is 40 mm. So this means that this will be my 20 mm. 20 mm. Okay, so we could do the extrusion for that. And the head thickness is 15 mm. Okay, so fine. So now let us proceed for creating the shank. Select this plane, select also an edge, and we know that the diameter of the shank is 24 mm. So draw a circle and set its radius as a 12 mm. 12 mm. So proceed for the extrusion of the shank. The shank length, let us again confirm it once again. The shank length was 28.5 mm. So 28.5 mm. Okay, fine. So let us also create one more portion for the head. And the radius should be 20 mm. 20 mm. And let us proceed for the extrusion. It's a 15 mm thick. Okay, so fine. So this means that we have created the bolt as well. Now let us also proceed for the partitioning. That is important for our meshing operation. So let us first partition this face along the diametrical axis. So we shall first proceed for partitioning to the sketch. So this is my face to partition, done. And I will select an edge also here. Okay, that's all set for me. So now let us draw the partition lines. This is one line, and let me also draw a vertical line. Okay, so this means that our sketching is over. So now let us proceed for the partitioning along these lines. So we'll use the same procedure. After this point, hit OK. So now select the cells once again. Done. Select this point, and we shall proceed for the horizontal line partition. Let's see whether it has been properly. Yes. So you can see that yes, the bolt is partitioned along the diametral axis. It is partitioned into 4 segments. Now let us also start partitioning at the interface of this bolt head as well as the shank portion. So for that we may have to create the data planes. So create for the data plane. So and it should be parallel to my XY plane, and the offset will be 15 mm. 15 mm. Okay. So you can see that yes, one data plane is already created. Now we shall create one more data plane and XY plane, and the offset will be obviously it's 15 plus. So let us proceed over here, and this is 15 plus of 28.5 mm, that is 43.5 mm. So we shall call it as 43.5 mm. Okay, so that is complete. Now let us proceed for the partitioning. So we shall use the partitioning using the data plane. Okay, so select the cells for the partitioning. Done. Now let us select the data plane. This is my one data plane. We'll create partition. Yes. So now we shall select once again. Done. Select the data plane. This is my data plane. Create. So now the partitioning operation is complete for the bolt as well. So now we shall proceed for the specifying the properties. So let us proceed to the next module, that is the property. So here we have two properties, one for the steel for the structural members and the other for the bolt. So let us start defining the material. So name it as a steel. So we shall define both elastic and plastic materials. So elastic. So define the modulus elasticity 2.1E5 and Poisson's ratio 0.30. We shall follow newtons and millimeters throughout this tutorial. And now going to the plastic. So we shall define the yield stress of 355, corresponding process strain 0, and then ultimate tensile strength of 470 at a process strain of 0.178. So that's all regarding the steel. Okay. Now let us define one more material, that is for the bolt. So we call it as the bolt. And let us define the elastic properties. So it remains the same 2.1 U5 and 0.30. So let us define the plastic properties as well. So we have a yield stress of 640, then associated plastic strain of 0, and then we have 800, and then a corresponding plastic strain of 0.08. So that's okay. Now let us proceed for defining the sections. So section we should define the section steel, and we will select material as a steel. Okay, and we shall proceed for one more section, that is a section for the bolt, and the corresponding material will be the bolt material. Okay, now let us start assigning these sections to the various components that we have already generated, starting from the column. For the column, let us assign the section. So assign the regions. Okay. So here the associated property will be my section steel. Okay, fine. Now let us take the other one, that is the bracket flange. So we'll assign the sections, select it, assign section steel. Okay, now go to the next one, that is the bracket web. So assign, select the regions, assign section steel to it. Okay, now we have the last component, that is the bolt. So assign the section, done. Now go for section bolt. Okay, so this means that our property module is complete. So we shall start covering the balance modules in the subsequent parts, part B, C, etc. So till then, bye.